Hey everybody, this is Larry. This is me going Q3 of the weekly contest for 32. Minimize the maximum edge weight of graph. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. This one I think can be a little bit tricky. I think my first instinct is actually my first instinct was binary search, which happens to be the answer. But I also kind of thought maybe there's some sort of greedy solutions that we can do. Which I don't know that there is. Honestly, I didn't explore the this idea of like creating a shortest path spanning tree type thing, and you can kind of just if you sort the edges, you can merge them in one by one. But that also ends up being n log n anyway, even if you are able to sort the edges. So I don't know. In any case, I did do it with binary search, and I think the hardest part is that each node has at most maybe I don't know about the hardest part, but the confusingest part is that each node has at most threshold outgoing edges. That is definitely a wrinkle, but the key observation here and the proof that and it took me a good amount of time, honestly, is that because every node has to be reachable from node 0, that means that if you only have one outgoing edge, that is enough, because by almost like an inductive kind of way, if your node connects to another node, and that node has to reach 0 by connect to at most one node, you can construct a tree for this problem. And that's basically the idea for this one. The idea here is that we do a binary search. Max number is just you go to the max edge weight, just to make it a little bit shorter, but you don't really have to. Oh, the other key thing to note is that even though n could be 10 to the 5th, edges is actually not n squared. I mean, it could be n squared, but it is at most 10 to the 5th, so that you can do something on the order of edges, and that'll be fine. But yeah, this is the binary search. I did max plus 5 just to be a little bit sure, so that we can get the impossible value, because if basically you add all the edges and it's still no good, then we return -1. Otherwise, to test a certain possible number, and in this case, we are binary searching for the value, which is the maximum edge that is inside the graph, right? So, and if a number is good, that means you could try a smaller number, because we already know a number that's the new upper bound. And if the number is no good, then we have a new lower bound, so we try a bigger number. So that's how we kind of construct this binary search. And here's the good thing, the good function. Honestly, I spent 22 minutes on this problem and a wrong answer, because I was trying to do it for each node, try to go to 0, but I went into issues with cycles, because for some reason I knew that it wasn't going to be a DAG, but I still kind of had weird notions in my mind, and I got them confused, to be frank. But the key idea is just going backwards. If every node can reach from 0, meaning that if we go from the other direction, then every node can be reached from 0 on an inverse graph. And that's basically how I construct this graph, right? Instead of u going to v, I go v going to u with the weight w, and I maximize the weight. And then for each one, I do regular reachability breadth first search, which is that, we start from node 0, we set it to done, we look at every edge pretty much as we go from node to node, and if we have not visited yet, and it is within target, or if it is smaller or equal to the threshold that or the target that we care about. I say threshold, but I guess this is a number. Again, we can ignore this, because at most, I guess if threshold could be 0, then that would be not good. But yeah, because it's at most at least one is good enough for every answer, and we can ignore it. And that's it. This is a regular breadth first search, so this is going to be linear in the size of the graph, and this is O of log m, where m is the maximum edge weight, or the number of bits. And that is all I have for this one. Let me know what you think. Thanks for watching. And you could watch me solve a live during the contest next, but let me show you this real quick. This is the top part of my code, and this is the right part, or the bottom part. And that's it. Thanks for watching. And you can watch it live now. If it times out, then Leetcode sucks. And I wouldn't have been surprised either, honestly. That's why I had to say it. But but okay. Let me just check the times real quick. 4 seconds is actually kind of scary. Okay, we'll think about it later. Up south. Okay, directed graph. Greedy. Binary search. The number of edges is some crazy number. Oh, okay, that's fine. I see. This is actually important. Yeah, okay. This is a medium. I don't like the double whatever pointers, but what's threshold? Oh, each. Okay, yeah, I mean, I think this is fine. Okay. Oh no, 10 to the 6. Huh, that's actually kind of wonky. Okay, let's process this. Okay, and then is it binary search? Double checking. Is it binary search? Do you need binary search or is it sorting? This is kind of hard. I don't know if this is true, actually, the binary search. Because you can greedily. No, binary search still should make sense. The threshold thing does not. Does it matter? How do we choose? How do we choose between two things to keep it under threshold? That's actually difficult, isn't it? No one's gotten Q4 yet. Okay. I don't think it's binary. So you filter the graph. Threshold, does threshold matter? Threshold does not matter because every other node by definition will. Okay. The threshold doesn't matter. Okay, I see. The threshold makes it so you cannot greedy add. But binary search is okay. I see, I see. That's why you have to do binary search instead. Okay. If this is good, then you want to try a smaller number. No, otherwise, you have to try a bigger number. Just do +1 really. Yeah, whatever, +5. Okay, I see, I see. Okay. Is it a DAG? Are there any cycles in this? They don't give us one with cycles, but so we have to do a thingy. This is one, okay. We have to, let's try. 1, 2, 2, 1, 2, 3, 2 to 3. Okay, so maybe I want something like 1 to 2, 2 to 3, and then 3 to 1, right? Is that routed input? That is routed input. So we have to consider cycles, so we have to do the coloring, right? How do we do coloring again? I forget. It's so so much easier with just a cycle, but okay. Maximum that we remove. Oh no, it's okay. So this is the maximum weight. So if this is good, then don't know if this is right. It's been so long, honestly. I feel like I'm doing this wrong, honestly. Okay, well, that definitely does not look good. But yeah, maybe that's fine. So that we're actually doing something. Okay, so we are doing something. But they all reach, all you need is one edge, that's why this works. But target is equal to 3. I don't think I'm printing it. The right ones, okay. Oh, 4 cannot hit 0, that's not true, right? Four cannot hit 0 with target is equal to target is equal to 3. Does anyone make sense that target is equal to 3? Did I look at the thing wrong? No. Huh. And debugging sucks too. So then why is plus 5? That's why I forgot. Okay, fine. That's fair. So if I do a whole graph, it should be true, right? So why is this wrong? Okay, so it's wrong because for 4 to 3 is 1. Oh, I do not update. Okay, 1, -1, -1, 2, -1. And then the other one is -1, which maybe is true, I don't even know. Okay, that is actually a very silly mistake. I don't know if this is right though, honestly. So that's YOLO. Oof. Huh? Apparently I output 92. Do I? Oh, max is 92. So okay, so that's not quite right, but expected. Oh, okay. So maybe my assumption is wrong about the thing. Oh, the threshold thing. Okay, so the threshold only matters for the initial. I think the initial input is bad. That's why 3 to 2, 3 to. Oh, threshold is 3. Huh? Okay, let's draw this. 3 to 2, 3 to 0, 3 to 2 again, 2 to 1, 1 to 3. Threshold is what again? Okay, but then we have threshold of 3. So that's just -1. 3 goes to 0, 2 goes to 1, goes to 3, goes to 0. Oh no, I output -1. I output -1, Larry, not the other way. Okay. So why do I output -1? Even though it's so the threshold thing is wrong. Oh, I guess it's just this part. I knew that this is awkward looking because we have multiple edges. I don't know how to do this with cycles. I guess I'm just sloppy today. This is very well known too. I'm bad. So 3 depends on the answer of 2. I don't know. Okay, let me think. The states of coloring. There's a cycle. What happens when there's a cycle? I don't know that I handle cycle well. I start with 1. 1 goes to 3. 3 goes to 0. 3 is good, right? So 1 is no bueno. Okay, at 92, 2 is no bueno. 2 goes to 1 goes to 3. But I guess there's something wrong with my cycle. Okay. Let's see. Yeah, that's what happens when you don't practice these problems. I feel like this isn't that bad, but I am bad. So force 0 to why? So it goes from 0, 0 is good, fine. 1, 1 goes to 3. At 94. Oh, yeah, debugging is terrible. How's Q4 doing? And one person got it, so I gotta get this one. And I'm not even doing that well. Okay. Well, 1 is good. Because 1 goes to 3, then 2. 1 goes to 3, goes to 2. Right? Maybe. 1 goes to 3, goes to 2. 2 returns force. Because 2 goes to 1. I see. And 1 was not ready yet. Okay, how do I do this? I'm doing this sillily. Okay. I know how to do it. Just look at it backwards. From 0. Yes, okay. I am dumb. I'm dumb. Okay, I got it. I got it, baby. Okay, I am dumb today. Okay. Yeah, okay. I'm trying to do something too dumb. Okay. New stuff. Okay, you got this. Okay, focus. Okay. How did I? Am I so? I just watched that one. I think, but my naming is terrible. I think I'm just a little bit turned around today. Okay, yeah, that's all you need to do, Larry. Okay, you want -1? Oh no, you want 92? I got 92. Yeah, okay. Silly Larry. Well, maybe sillier if this is wrong, so... Okay. How many people got this one? 91? I should have gone down earlier. I just... Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye-bye.